everyone, welcome back. It's great to have you here to revise simultaneous equations. We'll be going through some examples together, so please get your pen and paper ready so that you can work through these questions with me. There are three different methods to solve simultaneous equation. The first one is by using substitution. The second one is by using elimination. Now with this method, there are two techniques to help us to do that. And the final one is by using graph, which I think is the most powerful method. So let's go through them individually. The first method is by using substitution. So here is the first example. I have y equal to negative 3x plus 2. I also have 2y equal to 3x plus 10. With the simultaneous equation, what we wanted to do is to find some points, one or two or more, points that will satisfy both equations. What does that mean? So the first equation, I can find many points, infinite many points that satisfy the equation. For example, when x is 1, y is negative 3. When x is 0, y is 2. Similarly, with the second one, I can find infinite many points so that it satisfies the equation. But what we want is to find special pair of points. It will be both on the first equation and the second equation. Y in the first equation and the second equation should be the same if we are able to find such a point. And the x should be the same as well. Negative 3x plus 2 equal to y. First y is the same as the second y. I'll get an equation with only x. By expanding the brackets and solving the equation, what we have here is x is negative 2 over 3. And then because y is negative 3x plus 2, and we work out x is negative 2 over 3. So by substituting x into the first equation, I will be able to find y. Negative 2 over 3 and 4 is the point I'm looking for. What we can do is, by checking our answer, see if it's correct. I can substitute x and y back into my first equation, and I can see left-hand side equal to right-hand side. So the first equation is fine. Repeat the same process, put that x and y back into our second equation, as we can see left-hand side equal to right-hand side. So that means this is the answer we are looking for. So now let's look at another example. With this question, I have 4x plus 5y equals to 51, and I also have x plus 10y equals to 39. As we mentioned before, the first y is the same as the second y. So does it mean that I have to rearrange my first equation to make a y equals to 51, take away 4x over 5, and then substitute into the second equation? Now, as you can see, that y expression is so complicated. I want to make it easy. Now, we don't have to stick with y. We can see that x is actually easier to rearrange. So what I'm going to do in this question is to rearrange that second equation to make x the subject. And now I'm going to substitute that the second equation back into the first equation, and then the same process will help us to work out what is y. So in this case, y equals to 3. Now to work out x, I can use the first equation or the second equation. Obviously, the second equation is much easier, so I'm going to substitute my y into my second equation, and then that allows me to find x. So x is 9, y is 3. Again, we should always check our answers by substituting that x and y back into first and second equation. I'm going to leave that one with you. Now let's look at the third equation. Y take away x squared equal to 0, and y equals to x plus 2. Because in the second equation, y is already the subject. We write y in terms of x. So now what we can do is substitute 2 into 1, and then we will have a quadratic equation. Now what we need to do is to solve this quadratic equation. And now we find out x is negative 1 or x is 2. Because we have two x values, that means we should have two y values. So when x is negative 1, y is 1. When x is 2, y is 4. So in the end, we have x is negative 1, y is 1 as one set of solution. And then we have the other set of solution is when x is 2, y is 4. Now moving on to the second method, by elimination. We can do this by adding or subtracting or scaling. I'll show you what I mean. Now let's look at the first example. Now with this question, of course we can use the same method, make y the subject and then substitute into our second equation, like what we did before. But is it the most efficient way to do it? If we look at the equations carefully, we'll be able to see that there is a plus y and subtract y in the equation. If I have negative y, add an y, I'll be able to get rid of y. What we can do here is we can add two equations together. Now, if I have a left-hand side equal to right-hand side, I have two sets of equations. By adding them together, I should still have equation. I added the first one and second one together, I'll see 8x is equal to 14. So x is going to be 7 over 4. It's much easier than before. But to work out y, it's the same. We just need to substitute x into one of the equation, and then we find out y is 4. In the second example, we have x plus 3y is 14, and 2x plus 3y is 16. So in the first one, we have a negative y and y. When I add them together, I have 0y. That means I have nothing. They cancel out with each other. But if I do 3y plus 3y, I'll get 6y. I can't get rid of them. Instead of adding them together, what I wanted to do this time is subtracting them away from each other. In this question, you can do 1 take away 2 or 2 take away 1. It doesn't matter. I think 2 take away 1 will be easier in this case. It's because I don't have to deal with the negative numbers. Taking away 1 from 2, what I have is x is 2. In order to work out y, I simply substitute x equal to 2 into one of the equation. Find out y is 4. Let's look at a third example. In this case, I don't have anything in common. Coefficient of x are different, 3 3 and 2. Coefficient of y are different, is 2 and negative 3. So what should we do? There are two different things you can do. You can eliminate x or eliminate y by scaling. If I wanted to eliminate y, what we want to do is to make the coefficient of y the same. So I need to find the lowest common multiple of 2 and negative 3, which is negative 6 or 6. What I do is I multiply 1 by 3, so that will give me 9x plus 6y is 21, and I'll call that equation 3. I'll multiply the second equation by 2. I will have a 4x take away 6y, that is equal to negative 8. I'll call that equation 4. I can see that I have 6y and a negative 6y because they are opposite sign. I'm going to add them together. 3 add 4, I'll have 13x equal to 13. X is going to be 1. And then I'll just simply substitute that back into any one of the equation to work out y, and y is 2. What happened if I wanted to eliminate x? Let's have a look. It's the same process. I wanted to make sure I have the same coefficient. The lowest common multiple of 3 and 2 is 6. So what I need to do this time is I need to multiply the first equation by 2 and the second equation by 3. Because we have 6x and 6x, I need to subtract them from each other. So in this case, I'll do 3 subtract 4. I'll have 13y equals to 26. That gives me y equals to 2. And then we can do the same to work out x. You can eliminate x or y, but there's one thing you shouldn't do, is eliminating the number. Okay, so I've seen many of this. Just watch out. If I wanted to eliminate a constant, would that work? So what I wanted to do is I want to make the numbers equal to each other. I need to think about what is the lowest common multiple of 7 and 4, which is 28. I would time the first equation by negative 4. So then I'll have negative 12x take away 8y equals to negative 28. And then I'll times the second equation by 7. I'll have 14x take away 21y equals to negative 28. Now we have negative 28 on both sides, and then we can equate them together. As you can see, now in the equation I have x and y on both sides. I can't solve this equation because I have two unknowns. So you can eliminate x, you can eliminate y, but you can't eliminate the constant. Just be really careful with this. Now is the most powerful method by using graphs. So using graphs can help us to solve any types of question. What I'm going to do is I'm going to write out the questions we have solved so far on the screen with their answer, so then we can check by using graph. With the first set of equation, I'm going to type the equation into decimals. So the first equation, y equal to negative 3x plus 2, and then 2y equals to 3x plus 10. There is an intersection. It is negative 2 over 3 and 4. First set of solution is correct. We can solve any types of simultaneous equation by plotting the graphs, even if there are 3 unknowns. So with the second one and the final 3 questions, they will be the same. But with the third example, what we had earlier are 2 sets of solutions. What's happening here? Let's have a look. I will type in both equations. Y take away x squared equal to 0. It's a quadratic. If I plot the straight line, as you can see, there are 2 intersections, and those 2 intersections are the 2 sets of solutions we found earlier. That's all for today. Well done for making through to the end, especially if you have done the questions yourself. Remember, maths isn't a spectator sport. You have to keep practicing to be more fluent. Happy revising, and I'll see you in the next video.